We're going to go over Entity Framework debugging with SQL Server. Now we're going to concentrate on Entity Framework Core because as of now, Entity Framework 6 really isn't going to be kind of given any new features. It is going to be moved up to .NET Core 3.0, but that is only really so that people with current WinForm applications and other applications that use EF6 can move up and to core. So we're going to concentrate on Entity Frameworks Core. And the story around this is a couple of years ago, before I joined JetBrains, I worked in a lot of consulting jobs. And we were on this one big consulting contract where we were redesigning and rebuilding some educational software. And we had some really good DBAs on our team. And we had one DBA, his name was Nate. And Nate was really good because he actually wanted to learn more about the developer side of the data. So he actually taught himself a little bit of C#, enough to kind of get into Visual Studio and take a look at our source code, and so he could kind of see how and why and where that the queries were happening to going back to the database that he kind of controlled. And so we would have discussions, and he would come back and go, well, I'm finding that this query isn't running really well. Can we take a look at it? Can you tell me where it's at? And he would say, here's the query, and he would show me or show one of the developers, and we would go, okay, well, give me a little time to figure out where that query came from. And after a while, I had a discussion with him, and I said, well, why did you kind of learn? Because he actually was getting a little frustrated with us because we weren't understanding anything in his area. We weren't digging down into SQL Server to really know what was going on beyond that query going across the wire into his space. And he kind of wished that more developers would kind of learn how to use the tools that come with SQL Server. So that's where this talk comes from. So I'm hoping that we can all learn from that and do a better job when we write our queries, because just because a query runs and it gets data doesn't mean that query is the most optimized query that you can have. So let's take a step back. So my name's Chris Woodruff. I work at JetBrains. I'm a developer advocate for JetBrains, so I cover .NET. And as you can tell by my accent, I am not from Norway. I'm not from Europe. I'm actually from Michigan in the United States. So I am a developer advocate for North America for JetBrains, but I'm over here because they asked me to speak. I'm also not a DBA. So what we're going to do is go through some of this stuff more from what a developer can do with the SQL Server tools. You can get really advanced with these tools. I'm not going to do that. I only have an hour. What I'm going to hopefully get you guys to do is get excited about this stuff so you can go and learn more about it. And we're also not here to attack the DBAs. I mean, I've done a little DBA work in the past. I've been a database developer, not primarily, but some of my roles included database development. So I actually have a lot of respect for DBAs. And I know there's lots of jokes about them versus us and the whole throwing stuff over the fence. But I think we should kind of have a lot of respect for the DBAs that we work with. How many people actually work with dedicated DBAs on their projects? So some, okay. So what are we going to get out of this talk? So I'm hoping that we get three things out of this talk. So I'm hoping that we get the idea that we need to use the tools that come with SQL Server to better the Entity Framework use that we have. And also, I have some stuff in this that will help us improve how we use Entity Framework Core for performance and to make our users happier. And last, I hope that we all can get a better relationship with the DBAs that we work with or work with in the future, because it is important to have a little bit of understanding about what they go through and what they use and some of the tools. So the first tip I'm going to start with is just learning either what we call the query plans or the execution plans. So has anyone looked at execution plans? Okay, good. So this might be a refresher. I try to start with this in the beginning so that if people haven't seen this, they get a little more understanding about what they can do. So as an example, I have this query, and this query actually comes from one of the projects that I have for this demo that we'll take a look at. Now, this query is for a database that contains American baseball historical statistics. Now, baseball is probably not a big sport here in Norway, but it's a big sport in America. I love baseball. But what this query does is it queries the database for all of the pitchers, which is a position in baseball, all of the pitchers that were in the winning team of the World Series in no. Okay, I'm sorry. So this isn't that one. So that's the next one. So this one is over a database called Chinook. And Chinook is a test database that Microsoft released a number of years ago, and it revolves around the non-line music store. So as you can see up here, we have a customer, and we have invoices, and we have invoice lines. We have tracks, albums, and artists. So it kind of reflects all the data around that online music store domain. And what this does, it's going to list out all the tracks that a certain customer has bought. So, and if we take a look down below, this is the query plan that we get from SQL Server. And it's actually a good query plan. You can see that it will show you all of the subqueries and kind of places that it needs to get data. And you can take a look and see how much each kind of subquery inside this, how much percentage-wise it takes up. So you can see which areas take the most energy or the most effort to get back your data. But this is a good query. Now, so this is the baseball query. So this query, again, is getting the data for pitchers on the winning World Series team of last year. Does anyone know who won the World Series? I will be very impressed if anyone knows who won the World Series last year. No. Okay, that shows me that again, baseball probably isn't that popular here in Norway. So the Boston Red Sox won the World Series last year. So, and if I run this query from the application, what's going to show up is this query plan. And you can see I've highlighted this yellow area down below. And what this yellow area down below tells me is that even though there is data coming out of the database, and as a developer, I will get data back, and I can show that in my ASP.NET Core MVC application, it's not optimized because I'm missing an index that could help my program run faster. And so you can see that it says that I'm missing an index. It even gives me the SQL command to create that index. So that's why I'm saying if all you did was wrote your application, got back data, and said, okay, I'm all done. I'm good. I don't need anything else. You might not get out as much performance out of your application as you thought. Now, the other thing that this gives credence to is this idea of code first, like Entity Framework code first. Anyone do that with migrations? Okay. I'm not a big fan of that because you get a lot of this stuff. If you don't really understand and you don't develop those POCO models correct, you'll get a lot of areas where you might have some missing indexes. So if you do code first, Entity Framework Core, I would advise you to really look at all of your queries and take a look at all the execution plans, all the query plans for those to make sure that there aren't any missing indexes in your database. So if I take a look at where and in what area this is causing the most effort, the most cost for this query, you can see that the pitching is a table in my database. That is costing me 85% of what it took to get that query and to get that result set back to my application. So if I added that index and rerun this, I will get a dramatic increase in performance. So really, that's all. As a developer, that's all I'm really asking you to do is to go in, take a look at these query plans, see that there's no indexes missing or any other messages coming back from SQL Server to make those queries better. And also, just to understand where and how SQL Server is getting all that data to then bring it together in the result set and give it back to you. Because if you find, even though there might not be an index missing, you may see something is costing SQL Server in that plan the most cost. And you may sit down and go, well, because maybe this subquery or this area is taking up 60% of the cost of my query, maybe I can write a LINQ statement that's a little more effective than what I have. So this will give you some insight into writing better queries and better LINQ statements. So the next tip I want to go over is a new feature that's in Entity Framework Core. It came in at 2.2, and it's called query tags. So if you're a DBA, up till now, the only way that you knew where a query came from in a .NET application or a .NET Core application was to get the query and ask a developer. Really, it was that bad. It was, I have a query, it's not running well, I know how I can help you. You're missing a where clause that could improve your query by 200%, but I don't know where it's coming from. And that was the frustration that this DBA had, Nate, when he would talk to us, when we'd come back to us every few days asking us about these queries. So Microsoft actually added something to EF Core to help with that. So when you're writing your queries, these LINQ statements, we now have the ability to use this tag with method on LINQ. And tag with will allow you to add a string. And what this string does is it goes along with the SQL statement, with the query across the wire as a comment, and that will be put into the logs of SQL Server. So here's what I do with all of my LINQ statements now that I write. I have 3 tag with statements. One is a description of what that query does. The next one is I have a full name path for the method that the query comes from. So in this case, it is chinook.controllers.albumcontroller.index. So, and I just say method at the end. And then the last one, the last string I send over is any parameters. Now, I can't do string interpolation with tag width right now. So I can't actually put the parameter value into this. All I can really say is what the parameter is. Like if you were in maybe if it was customer ID, you could just say a parameter for this is customer ID. So what gets sent over and gets logged into SQL Server is this. So you can see that the select statement that gets generated from Entity Framework Core is down below, and above it are these comments, are the comments that go across. And they are just like you do in your strings. It doesn't change anything. It just adds those to the query and sends it across the wire. But what this will do is when, and we'll take a look at this in a second, this will give your DBAs or you or anyone else that finds issues in the database, it will give them a little more information on how to go back to the developer and say, I have this query, it exists in this namespace, in this class, in this method, can we sit down and talk about it? Which will save a lot of time dealing with stuff. So this is a great feature that was added to SQL Server. Now on the SQL Server side, we have this idea of extended events. And extended events goes kind of hand in hand with this idea of query tags. So let's take a look at that. And this is just the way to create a extended event session. So we have to give it a name. We have to give it at what event we want to fire this off. And this will be done at the SQL statement completed. So anytime a SQL Server SQL statement gets completed, and it will go out and take the SQL text and check to see if the SQL text has that search, that wildcard search down below. So if it finds select an album in the SQL text, it will log a event into this queue and allow you to take a look at it. So we'll take a look at that right now. So let me shut this down, and we're going to bring up our editor, and we're going to bring up actually SQL Server Management Studio, and hopefully you guys can see this. I can't increase the font in this anymore. Now, underneath management, if you go underneath your server and you go underneath management, and then you go underneath extended events and then sessions, you'll see that you can have these sessions that you created, and you can start and stop them whenever you want to. So I have a bunch that I created for this demo, for this talk, and one is called Chinook Customer Queries. And if you right click on that, you can actually look at the live data coming across. So these are all the queries that extended event caught. So these are all the SQL statement completed events that were that this caught. Now I can come in here and take a look and see the details of this. And if I double click on the SQL text in here, and okay, there we go. What you can see, and I again apologize for maybe not having, I can't increase the size of this text large enough really to see it, but you can see that the comments from the query tags are shown at the top. So you create these extended events, and you can actually put in very complex where statements to say, if a statement goes over a certain amount of execution time, I'll log this event. Or if it consumes this much memory, I'll log an event. And so I break it down to where different entities in my Entity Framework Core code. So if I have 12 different entities, and that's why I have in Chinook, the Chinook database, I can set up a bunch of different events to catch different things to do with those entities. So that if something isn't running well, because maybe I changed a LINQ statement or someone changed something, I can see those events in here and I can take a look at those, and I can see the query tags and know where those statements were coming from. So this idea of extended events is really important. Probably most of your DBAs know all about it. It's been out since SQL Server 2016. So it's been out for a little while. So it's a nice feature as a developer to know about, because if you don't have a DBA, it kind of allows you to not have to concentrate on the database all the time. And you can set these events up and come back on maybe a weekly basis, or if you're doing some kind of testing, say you're going through some kind of smoke test for integration testing for a new release, you can test out your application, and then you can come back to the database and check out these extended event queues and see if anything was caught from those tests. So it's a good way to kind of catch those from the database side. Okay, so we're going to go back and move on. So the next idea that I want to go through is learning about Query Store. Has anyone looked at Query Store? It's another new feature from roughly around SQL Server 2016. And Query Store is kind of like your KPI for your databases. So first we're going to understand a bit more about it. So it was added to give you some reporting stuff about your databases. So you can, by default, there's stuff that you can see your queries that consume the most resources, queries that take the most time to execute. And there's lots of ways to configure these reports and these kind of feedback from the Query Store. Now, how you turn those on? The best way I like to turn on Query Store for a database, because by default, it's not on when you first create your database, because it actually will take up roughly 2 to 4% execution during when it's on. So there is a slight impact on your database to run this. It's not too bad. But if you are in a project and you need the most optimization, the most power in your database, you probably should turn this off, because it might have a little too much impact if your database has a huge amount of users hitting it. So maybe you just turn this on your development databases or your QA databases, or maybe you just turn it on for short periods of time during production just to get a snapshot of what's going on in the database. But this is the SQL statement to turn it on. So it's just an alter database call, and you give it the database name, and then you just set in the Query Store to on. So let's take a look at the query store real quick. So again, you go through SQL Server Management Studio. It's a feature in here, but this is at the database level. So up here, I'm going to take a look at Chinook. Underneath Chinook, there'll be a folder called Query Store. And there's a number of different areas that Query Store gives you underneath. So again, we have regress queries, overall resource consumption. So the ones I kind of take a look at are the overall resource consumption and then top resource consuming queries. So let's just take a look at overall resource consumption. So if I double click on this, you'll see that there's 4 areas that come up. So I've got duration, execution count, CPU time, and logical reads. And you can see that these are spanned out across time. And I can actually configure this so that you can shorten this. So you can also show charts for a number of other areas that the query store can oversee. But you can also see, like, maybe I just want to take a look at the last 2 days. So if I take a look at the last 2 days, it will change those charts to show me just that time frame. And then what I can do is, say I do execution count, I can come in and just take a look at that one area, that one slice. And in here, I can take a look and see what are the queries that are causing the most execution count in my database. And a lot of these are system queries and stuff. So you might have to dig in. So this one is actually one that's coming from my application. And so it is the 4th most query that is causing an impact for this area for execution count. And you can see that it shows if I'm highlighting this, it'll show the query plan underneath here. And if there was some missing index or something that was shown in this query plan, I could take a look at it. Now, so this is also nice because this will give you some insights into your databases on certain servers that you may have to look at. So you may find that looking at maybe the last couple hours, if people are saying, hey, the application looks really slow, the application isn't getting data back that quickly, you go in to this query store, take a look at the last couple hours, and identify those queries quickly based on certain criteria that you want. Maybe it's logical reads, or maybe you want to see execution count or duration. So there's all these different ways that you can dig in here quickly and effectively without having to go in and run a bunch of queries and know about the system tables underneath these. Because what these are really doing is they're really just querying the system tables inside that database to get back data and to show you in a visual way based on those query plans and the execution plan data that's saved out in like the transaction logs and stuff like that. So query plans are a really effective way to allow you to be your own DBA in a way. So I always like to show this also so that people can go back and really dig into this and learn more about the query plan. What's that? Yeah, you could. Yep. And you can export the data. So if you were running a bunch of tests and you needed to document certain things, you could export this and you can export it in PDF or XML, and you can present that with maybe your documentation on a new update or something like that. Or if you found a bug and you had to log the bug before you fixed it, you could kind of take this data and say, here's a query store data, like a snapshot from the query store that's showing the areas that are impacting my application, and then whoever gets that bug fixed that needs to fix that bug later can have that to work on. So anyone have any questions up till now? I mean, most of this stuff, I didn't know a lot of this stuff up to about a year and a half ago. So this was really a lot of interesting stuff for me. And I also have a lot of DBA friends. I'm on the board of PASS, which is a big data association. And when I was talking to people that were on the board that do this DBA work for their career, they were impressed that I was even interested in it. So that kind of reinforced that I think we should all take a look at this. So the last area that I want to take a look at is kind of stepping back out of the database and into your application, and 3 areas that new features of Entity Framework Core I think can really impact the performance of your application and also improve the queries that are sent over. So the first one is this idea that we can do string interpolation in raw SQL methods. Now, we all remember the days where we would send over a hard-coded string over to SQL Server and get data back. And what was the bad side of this habit? Anyone? SQL injection. Yep. So Microsoft sat down, the Entity Framework Core team sat down, and they wanted to allow people to send over raw SQL statements, because I don't know about you, I've hit points where I can't write a LINQ statement to do what I need to do, but I can write a SQL statement to do what I can do. Or maybe a DBA, and I ask a DBA to do a query for me, and they write a query, and it runs perfect. It's highly elegant. It's optimized. And I don't want to bring that back into a LINQ statement, because maybe that LINQ statement won't match the elegance of the query. It won't match the SQL statement that's coming out of the LINQ statement won't match exactly one-to-one to the query that the DBA gave me. So I can actually use this new feature from SQL to send over those SQL methods and SQL statements. So in this case, I'm just doing a select star from customers where city equals something, and above I have Redmond. So what that actually does now is sets up and sends over 2 statements, and I don't have the one in there, but it actually declares a SQL variable called P0 and sets P0 to Redmond, and then it sends over a SQL statement with a reference to that declared SQL statement. So that will allow it not to have SQL injection. And how this is done is in C#6, we had this new idea that we could do string interpolation. It was a new feature in the version for C#, and we have this new string type called formatable string, and that is actually the second C# code segment is actually what's being done in the first one. We're just not setting and not declaring the formatable string type in the first one. So I just wanted to show that we could either do it like the first statement, the first example, or we could set it and use that formatable string query. So this will allow you to send over raw SQL statements that maybe you've developed or your DBAs have developed so that you can run the queries that they have developed for you. Because I know in the past I've gotten statements and select statements from my DBAs, and I have spent a day or two trying to get those in the LINQ because that was the way that we were to do queries and stuff. And they didn't want to build maybe a stored procedure or something for me to call with that query. So this is just kind of the first area that I like in the new Entity Framework Core that really allows me to do a much better job with querying data. So the next one is explicitly compiled queries. So when we build out our .NET or .NET Core applications and we have these query statements and we build them and then we say like var query equals some LINQ statement. Every time we call that statement, that LINQ statement has to be compiled. And if you call that 1,000,000 times a minute, that LINQ statement gets compiled 1,000,000 times in a minute. So we have this new way to actually pre-compile a LINQ statement and use that compiled LINQ statement over and over again in our applications. Which, if you're building maybe an API or an application that uses a loop or uses some kind of delegate to call some other LINQ statement, or a LINQ statement that does a lot of internal conditionals and looping, this could really impact the performance of your application. So explicitly compiled queries help out. And how we build these is we put these in the DB context. So this example is a private static read-only function. I give it a name of underscore query get all albums. So what this is going to do is just get all the albums from the Chinook database that we are working with. And you can see that it's asynchronous. We're using the async enumerable of type album. And we use the new method called ef.compile_sync query. And what this will do is it will make a function call, a function reference of that name, and it will have that LINQ statement in there to use over and over again. And how we call that is all we have to really do is just have I have another method that my data repositories can call called get all albums async, and it's await because the original compiled query function is asynchronous, and I just call that. I give it the DB context that we're working with. So I say this because I actually have this call inside my DB context that I can call and get this data from my database, and then I just send it out in a to-list async. So let's take a look. I do want to show you guys what it looks like from a coding standpoint. So if I open up this project. So this is an API project that I do a lot of talks around from an architectural standpoint. But in this solution, I have two different data projects. One is I use EF Core, just normal EF Core with non-precompiled queries. So all my link statements get called like normal, and they get compiled as I need them. But I have this other data project that I can use, that I can consume through dependency injection. And this one is called Data EF Core Compiled Query. And again, if I open up and I'm looking at the Chinook context, which is of type DB context, I have a number of these compiled, these function calls, these function creations that take all of the link statements that were in my data repositories doing this, and I precompile all these, and then down below in the same DB context, I have a number of these public functions that I can call to then call the compiled queries, and we'll get those the data back from the database. And I've run tests between the two, the non-precompiled project and the compiled project. And in this API, I'm getting between 25 and 30% increase in performance through testing. So you can actually get a lot of performance out of your ASP.NET Core application. In this case, this is an ASP.NET Core 2.2 web API project or solution, but you can do this for any project, any type of web application that you want. And it wasn't that hard to do. It took a little bit of time to move and refactor those link statements out of my data repositories into the DB context. But once it was done, I was amazed at the increase in performance.
Question?
Yes.
So when you say they are compiled, what are they compiled into?
They're jitted down. They're jitted down into IL. So they're actually IL that is in your project, in your .NET Core project. So nothing has to be rejitted in the application for those link statements.
Thanks.
Yep. So the last area that I really love about Entity Framework Core is DB context pooling. And DB context pooling is a simple thing to do, but it will give you a huge amount of benefit from. So in this case, in this code, I have a kind of a small example from my album repository in that last solution I was showing you. So in here, I have a album repository. I'm using the repository pattern for my data access. And I have a private variable called myDBContext. And that gets brought in from the dependency injection container through my class constructor. And then I just have one method down below that just calls and gets back all of the albums. So this is just doing a simple link statement, just says dbcontext.album.toList async, and away I go. In a traditional way, if you don't use DB context pooling, and we use the pooling, or we use the traditional way that we use the DB context in our application, every time you called this method, the getAllAlbum method, it is going to create a new instance of that DB context for you. So every time you need that DB context, it creates a new one for you. So if you're running, again, if you're calling and you need 1 million DB contexts in a minute, per minute in your application, it will create 1 million DB contexts for you in that minute. So every time you do it, there's that overhead of creating the DB context, getting it stood up, setting everything up in it, and then sending it across the wire. With DB context pooling, we actually now have a pool of DB context objects that are initiated at the start of the application and put into the DI container for your application to use. And as you call and need this DB context, it actually will take it out of the pool and give it to your application. So you don't need to stand up a DB context. You don't need the initialization. It does that in the beginning. Now you're going to get hit with that in the beginning of your application. So the first time your application gets stood up, 32, right now, I've only seen 32 instances get inserted into the DI container. So 32 instances of your DB context gets created, gets initialized, and gets put into that pool. And then you're off and running, and you can use those DB context as needed. And when they get put back into the pool, they're actually stripped of all their state. So if you used a DB context and you did a bunch of updates with it, when that DB context goes back in the pool, the state of that DB context goes back to a beginning state. So it loses all of the knowledge of any of the updates or any of the queries that it did while it was out of the pool being used. So if you need your DB context to remember the updates that it did or the changes that it did in the application, this might not be the best way for you to go with pooling. But I don't really save a lot of my state. I try to keep my applications as stateless as possible, especially APIs. I build a lot of APIs, so those APIs, I don't want them to know the state. So I'm fine with losing that state when they go back into the DI container. But again, each time they come out, each time you need a new DB context, it will actually pull it from the pool, give it to the application through the constructor at the creation of that object, and then when it's done, it brings it back into the pool. So again, I've done tests to how well this performs by not using pooling and using pooling. And again, it's about a 20% increase in performance. So I've seen by using explicitly compiled queries and DB context pooling, I've gotten about a 35 to 40% increase in performance in my ASP.NET core applications. So there's a lot of great features in EF Core. I do a talk on just all the new features, and these are just the 4 features that we went through in this talk are a number of them. I do about 12 in my other talk. So if anyone wants to know more, I'll be available after this talk if you want to sit down and talk more about EF Core and geek out on that. I can even run through a little slide deck and show you where in EF Core, you can improve your applications even more. So how we set this up in our application and tell our application, tell our DB context that we want to use pooling is in the startup class for our ASP.NET Core application or project. In the services, when we set up services, everyone who's done core development should probably recognize this. It's just services dot add DB context, and then we give it use SQL Server, and then we give it the connection string. And this will set up your DB context and allow it to know where and what database server it needs to be connected to. So all we have to do is switch out that add DB context and add DB context pool. There's a little bit more to it, but I haven't found, I've done probably 20 different projects where all I've done is really change that one call, and they all will work out of the box. But you may hit an error that your DB context has to be changed. Maybe you did some modifications to it, and pooling won't work. You'll just have to go back and fix. There's some errors that come up that will tell you what you need to do to get your DB context to allow it to pool. But for the most part, DB context pooling is just that simple, and you'll get that benefit the next time you start your application up and get it running, and it will do that pooling for you. So I have 8 minutes left. I just want to really end on this note is I hope everyone is nice to their DBAs. I hope you guys learned a little bit more about some of the SQL Server tools that we need to learn about as developers. I'm not saying you have to become a DBA or dig in and learn everything about execution plans and the query store, but learn enough that if you sit down with your DBA or someone that is doing the DBA responsibility on your team, you can at least talk to them and understand where they're coming from. Or you can say, hey, I found this query. It's not executing well. I just want to talk to you about it. I mean, they'll buy you a coffee. They might even take you out to lunch. They'll be so happy with you guys. But be nice to your DBAs. They work as hard as we do. And a lot of times they don't get the credit that we do as developers because kind of developers, I will admit that developers take a lot of the credit for the applications that we write because it's kind of the first thing that users see. But DBAs are usually the people that get all the blame because we can say, well, it's the database. The database isn't giving me data correctly, or it's not giving me data efficiently. Well, that shouldn't be an excuse anymore. It should be a reason why we need to learn more about the database and what the database does. So I'm going to wrap up. If anyone has questions, like I said, I'll be outside answering anything. Or if you do want to take a look and talk about other features of EF Core that we didn't talk about in this session, I'll be around for a little while after this. If anyone wants to contact me, that's my email address at JetBrains. And then if anyone wants to take a look and get that sample code that I used, I didn't really show a lot of it because it was all in slides. But if you do want to take a look at it so you can go back and take a look at a program that uses some of the stuff I talked about, you can go out to my GitHub account and grab this repo and clone this repo and use it. So it's just debug EF Core with MSSQL. So again, I really appreciate it. We have 5 minutes left. If anyone has questions, I'll answer any questions that you guys have. Yeah.
Is there a way with EF Core to see what emits to SQL Server?
Yeah, so if you, in this project, in both of the ASP.NET Core MVC applications or projects I have in this repo, they have logging set up. And that logging is just another, it's set up in the startup, and as you execute this, you'll see through that the logs that get thrown out on the console, you'll see what the SQL statements are that are being given to the SQL Server, and you'll see the comments that are given to it from the entity or from the entity tags.
And it's all the commands, even the set that are sent.
Yeah, so it logs it. I set it up to log everything. Yep, it's like a debug log. Yep, you're welcome. Anything else? Okay, well, I appreciate everyone coming out, and I hope you guys had a good conference, and you guys have a nice weekend. So, and I have really enjoyed being in Oslo, so thank you very much.